Bismillahirrahmanirrahim. Dear students, today we discuss a rational number and irrational number. But some history. Around 5000 BC, the Egyptians had a number system based on 10. They used symbol for 10, this. Symbol for 100, they represent 100 like this. And the vertical strokes or bars such that 1, 2, 3, 4 were used for the numbers 1, 2, 3, 4, etc. The symbol 5 vertical bar was used the symbol by many people including the ancient Egyptian for the numbers of fingers of one hand. Now, for a rational number, we must understand some basic definition which I am going to use in rational numbers. The first one is number. Now, what is a number? General definition is any idea, word or symbol indicating quantity of units is called a number. Or mathematical definition is a number is a mathematical object used to count, measure and label. The original examples are the natural numbers. For example, 1, 2, 3 up to so on. The next basic definition is prime number. Now, what is prime number? A number that has only two factors, that is itself and 1, or the number has only two divisors, that is 1 and itself. For example, 7 is a prime number which is evenly divisible by 1 and 7. Now, a very interesting fact about 1. The question is 1 is a prime number? The answer is 1 is not a prime number because it does not have exactly two different factors. Because of uniqueness property, 1 is not a prime number. Got it? Okay ji. So next definition is a relatively prime. Two integers are a relatively prime or co-prime if there is no divisor other than 1. That is, their greatest common divisor is 1. For example, 12 and 13 are relatively prime because their greatest common divisor is 1. But 12 and 14 are not relatively prime. Okay, next, integers. Simple definition, an integer means a whole number. For example, 21, 4, 0, minus 2, minus 8 are integers, while 9.75, 5.5 and under root 2 are not integers. Now, what is a rational numbers? Definition: a number which can be written in the form of P over Q. Now, what is P? What is Q? We have to check three conditions in order to check the given number is a rational number or an irrational number. The first condition is P and Q are integers, that P and Q must be belong to set of integers. Okay. Second condition is P and Q are a relatively prime, mean their greatest common divisor is 1. And the last condition is q is not equal to 0, because anything divisible by any number divisible by 0 is undefined. So we must check three main points in order to check a rational numbers. Now, rational number can be subdivided into four different different parts. First one is fractional form. Second type is perfect square root. Third type is terminating decimal. And the fourth and last type is recurring decimal. Now, first we talk about what is fractional form. Number one is fractional form or common fraction. For example, 5 over 3. This number can be written in the form of P over Q, first condition. Second condition is P and Q are relatively prime, yes. Third condition is Q is not equal to 0. So all the three conditions are satisfied. So the given fraction is a rational number. Another example of rational number or common fraction is 5. Is 5 is a rational number? Yes or no? Think about it. Yes, because 5 can be written in this form 5 over 1, which is P over Q form. P and Q are relatively prime and Q is not equal to 0. So we can say that 5 is a rational number. Or you can remember this as all integers are rational numbers. Okay. Next type is, the second type is perfect square root. All perfect square roots are rational numbers. For example, perfect square root of 16 is equal to plus minus 4, and plus minus 4 can be written in the form of 4 over 1, which is P over Q form. They are relatively prime and Q is not equal to 0. So all perfect square root are rational numbers. Got it? Third type is terminating decimal. Terminating a decimal which has only a finite number of digits and its decimal part is called a terminating decimal. For example, 0.5 is equal to 1 over 2. This is example of a terminating decimal. 0.5 can be written in the form of 1 over 2, which is P over Q. They are relatively prime. Q is not equal to 0. So it is a rational number. The fourth, and there is another example of a decimal or terminating decimal, which is again a rational number. And the last and fourth type is recurring decimal. A periodic or recurring decimal is a decimal in which one or more digits repeat indefinitely. For example, you can write 4 over 3 as 1.3333. Here 3 repeated indefinitely. This can be written in the form of P over Q, and P and Q are relatively prime and Q is not equal to 0. So we can say that it is a rational number. Okay. Now, an important note. Unlike natural numbers and integers, there are countless rational numbers between any two given rational number. There are countless rational numbers between any two given rational numbers. Now, I am going to make a connection with horned lizard as an animal. It's a reptile, a lizard, and a gecko. Rational numbers are classified this way as well. Now, Numbers, irrational numbers. The simple definition of irrational number, the numbers which are not rational are called irrational. It's a simple definition. The number which are not rational, obviously it is irrational number. Or you can just remember this as non-terminating or non-repeating decimal. Or you can say that they cannot be written in the form of P over Q, the quotient of two integers. And the third one is under root of any prime number. Suppose n is a prime number, under root of any prime number is an irrational number. If a whole number is not a perfect square, then its square root is an irrational number. For example, under root 2 is not a perfect square, so under root 2 is an irrational number. Got it? Now, what is a real number? The real numbers include all the rational numbers and all the irrational numbers. You can say that R is equal to Q union Q dash. Q is a set of rational number and Q dash is a set of irrational numbers. So it includes rational and irrational numbers. Now, we revise our today lecture with the help of Venn diagram. Mean natural numbers. Whole number contains natural number, integer contain whole and natural number, and rational number contains integers, whole and natural numbers. And the number which are not rational is called irrational number. We can remember this rational number or real number with the help of tree diagram. You can see real number can be subdivided into irrational number. Irrational number is non-terminating or non-repeating decimal or number which cannot be written in the form of P over Q. For example, 3.1415. It's a non-terminating, non-repeating decimal. And the second type is rational number. And four type of rational numbers are fractions, 2 over 3, 4 over 5. Second type is terminating decimal, 1.2.5. Third type is repeating decimal, for suppose 1.333. And the last type is integers. And integer can be subdivided into two parts, mean negative integers and whole numbers. And whole number can be divided into two types, natural numbers and 0. So you can remember real numbers or rational and irrational number with the help of this tree diagram. Okay, or you can just remember our today lecture with the help of this real number containing a rational number containing natural number, which is 1, 2, 3 up to so on, and whole numbers 0, 1, 2, 3 up to so on, integers, positive, negative number including 0, and decimal form either terminates or repeat. And the number which are not rational is irrational. Decimal form is non-terminating and non-repeating. Okay. Okay, state if each number is rational, an irrational, or not a real number. For example, check this out. Under root 49 is a rational number or an irrational number. Think about it. Good. Yes, under root 49 is a rational number. Why? Because 49 is a whole number that is a perfect square. So perfect square is always a rational number. Under root of a perfect square is always a rational number. The second example is 0 over 3. Is it rational or irrational? Think about it. Yes. Yes, it is a rational number because it can be written in the form of P over Q. P and Q are integer, P and Q are relatively prime, and Q is not equal to 0. So students, we can say that it's a rational number. The next example is under root of 23. Is it a rational or an irrational? Okay, think about it. Yes, it's an irrational number. Why? Because although 23 is a whole number, but it's a prime number, and prime under root of any prime number is an irrational number. Got it? The fourth one is 9 over 0. Is it rational or irrational? Think about it. Rational. Yes, because it can be written in the form of P over Q. P and Q are relatively prime and Q is not equal to 0, but third condition is not satisfied. So it is not a rational number because 0 can be cannot divided by 0. Any number can be divided by 0 is equal to undefined form. So it is not a number. And then the last example is 64 over 81. Is it rational or irrational? Yes, it's a rational number because perfect square root in numerator as well as denominator. Now, a very interesting question about a number. Number, which kind of number define pi? And the question is pi is a rational or an irrational number? And give your answer with reason. So first of all, I define pi. What is pi? Pi is a simple ratio of circumference of any circle to length of its diameter. Mean the boundary of that circle is a purple line indicating circumference of the circle, and the line passing through center of the circle is called diameter, and the ratio between circumference and diameter is called pi. You can remember this as CD, alphabet as alphabet CD. So ratio between CD is called a pi. The simple definition, got it? Now, is pi is a rational or an irrational number? In childhood, we used to write this pi is equal to 22 over 7. Am I right? Is it right? Okay. Now, what is 22 over 7? Is it rational or an irrational number? Yes. It's a rational. Why? This can be written in the form of P over Q. They are relatively prime and Q is not equal to 0. So we can say that this 22 over 7 is a rational number. Or in points form, you can see that very interesting fact that after 6 digit repetition occur. So repeated value is also a rational number. But what about pi? Pi is equal to 3.14159265 up to so on, non-repeating decimal. So pi is an irrational number. Got it? Then how is it possible that a rational number is equal to an irrational number? Is it right or wrong? Yes. You cannot write pi is equal to 2 over 7. You write it as pi is nearly equal to 22 over 7. Just remember this, a very important point. A repeating decimal may not appear on a calculator like this. When you divide 22 over 7, this cannot be happen. After 6 digit repetition occurs. So be careful while using your calculator because calculators show a finite number of digits. So students, lastly, I will give you some question to check whether they are rational or an irrational, and please give answer and reply in comments. The first one is fifth under root of 4, second one is 1.3 bar, and third one is E. Give your answer with reason. Hope you enjoy our today lecture. Inshallah, we will meet in next lecture.